Within an aquifer, the water table is rarely horizontal, but reflects the surface relief due to the capillary effects in the soil, sediments, and other porous media. In the aquifer, groundwater flows from points of high pressure to points of low pressure, and the direction of groundwater flow typically has both a horizontal and vertical component. The slope of the water table is known as a hydraulic gradient, which depends on the rate at which water is added to or removed from the aquifer and the permeability of the material. The water table does not always mimic the topography due to variations in the underlying geological structure. The aquifer around North Creek appears to be unconfined since there are seeps that come from the surrounding landscape that feed into it. Here we are on the hill above the library, and you can see creeping buttercup and horsetail, which are both indicator species of wetland-like conditions. Think about it. Many people get the water they use from aquifers. Sometimes it seems there's an unlimited supply of water coming from the ground, when in fact the supply is very limited. People use groundwater for all types of reasons, from agriculture to washing their cars. Did you know it has taken millennia to amass that large of a reservoir? Did you know that many of them are draining faster than we can recharge it? Let's talk. Do you know where your groundwater comes from? How deep does it come from? How long do you think that water stayed underground before you used it? 1, 5, 100 years, or maybe more? Moving materials. Topography plays a major role in the direction of water flow, but water also plays a major role in topography. Streams carry sediment along with other materials such as woody debris. These materials get deposited along the channel and it can permanently alter the topography of the landscape. Streams can also change course, causing the water to gouge deeply into the landscape, leaving its permanent mark on the landscape. Think about it. The amount of material a stream can carry is enormous. Many rivers carry tens of thousands of tons of sediment every day. With a capacity like that, you can start to understand how water is capable of changing the topography of a landscape. Let's talk. When you have looked at streams, have you ever said, how the heck did that big rock get there? Moving this much material seems like it could be very destructive, but is actually a good thing. Can you think of some of the benefits from moving sediment? The watershed. Topography is the shape and physical features of land. The topography of a stream channel and its watershed reflects the geology of the watershed. In turn, watershed topography helps produce the pattern and distribution of stream channels. Topography of a watershed also determines the steepness of the land surface in stream channels. We also know that steepness is slope, grade, or gradient. The height and steepness of the hills, floodplains, and channels contribute to the erosive powers of the water and in the watershed. Steep slopes allow the force of gravity to quickly accelerate the speed of water flowing. The faster water flows, the more energy or power it has to erode or move soil, sand, gravel, or boulders. Topography also affects the sinuosity of the streams. Channels with low gradients usually meander back and forth, while steep channels do not wind back and forth but have more riffles. Think about it. Does any portion of this watershed description seem like where you came from? Let's talk. What is the stream shape where you grew up? Does it seem like the stream channel has been straightened or modified? Does it look different from the channel in the North Creek wetlands? What do you think the watershed for the North Creek wetlands is? Do you know what watershed you live in? When you look at the flow of water in North Creek, can you estimate its gradient?
So there are many depressed and raised areas that supports a diverse array of life and vegetations. Like you can see further ahead, there's like little depressed area. So during rainy seasons, you will get up waters and form like ponds or something like that. So it's very important to the species because sometimes it creates a protection and barriers for them to live under. And then sometimes those areas will give like a water source to some animals, birds. It's also very important to some amphibians for them to live in between lands and waters and feed off the species in the water. So I want you to think about how are they formed, and was it formed purposefully or it wasn't. So you know, because this North Creek is restored after the Truly Farm, so is it purposefully to restore it that way, with like a raised and depressed area, or just happen to be that way? So I have a few questions. So are there any type of amphibians that you can think of or that you know that lives around pond in this kind of environment, like living off depressed areas or something like that? And how the raised area are benefit to the ecosystems in North Creek? And what kind of species or planes lives on the raised area or depressed area that you can identify right now, if you can see? And how are the ponds formed in depressed area in North Creek by observing the area right now? So what? So variations and turns. As you can see, North Creek to Utah Bothell has a pretty big difference of in elevation. And not only so, the terrains within the wetlands have some noticeable elevation as well. As you see, like northwest part of the wetlands actually higher than the southwest part of the wetlands, as you can see before when we were talking about the depressed area. So I want you to think about if you know how the terrain affects of the distribution of the wildlife in the wetland environments. In other words, so how does the terrains affect the distribution of the wildlife? Like in higher parts of the wetlands, what kind of animals or species live there, or in lower part of the wetland, how does the lower part affect the species live there? And it might have something to do with what we talked about on depressed area, how there's water in there, and maybe in higher part of the wetland there isn't. So yeah, I want you to think about it. And then I have a few questions for you. So how are the terrains formed? Then why is it that way right now? That one side is higher, maybe one part is lower. And is there any natural force that you can think of make the terrains the way it is now? Maybe you can tell, maybe when there's a water stream down ahead, and that makes a difference on the wildlife that lives in a higher terrain and lower part of the wetland. And then is it possible that this terrain was designed by the humans, was formed purposefully, or is it not? So North Creek has a drier part of the wetlands that is northern of the North Creek and closer to UW. And then it also have a wetter part of the wetlands that's closer to the river or the stream. Well, it's summer now, so there's pretty dry here, but maybe during spring or fall or winter when it's rainy, you can see the part that is dry and the part that is wet. So the part that is wet actually have ponds or mushy, or when you go down further to the river, you can see pretty marshy areas. And then each different part supplies different species, from grass to trees to maybe birds and insects, and then to amphibians or fish. So I want you to think about, I will show you the satellite of the North Creek wetlands and then UW, and then maybe you can point out where's the river and how was it channeled from original channel, and then point out the wetter part and dry part of the wetlands that you thought of. So I have a few questions for you. How is the drier and wetter part of the wetland formed that we just talked about? And then how, I mean, are there any specific species you know that only lives in either wet or dry part of the wetlands, or both, just if there's any that you know? And then, why does it matter when a wetland has a drier part or wetter part of the wetland?